tamper detection and stuff. So what you could do with the clock, actually I'll use this example again. The area that we cut out of this time-based token was to access the crystal, which is a 32K, just standard clock crystal. By changing the clock signal, by speeding it up, we could view more iterations of this particular device, which would give us, I'm trying to be a little covert about it, but I think people know what it is. Every 60 seconds we got a new number. So what we were doing is by speeding up the clock, we'd get more numbers, which we could then look for repeated sequences, possibly to see if we can determine the secret based on the numbers that we get. And then by slowing it down, we could single step, make it easier to do external measurements with like logic analyzers and all those tools. But definitely for like time-based things, speeding up the system is going to lead to some interesting things.
And one other thing you can do is in many more complex systems, there's actually different clocks in the system. And if you could slow one down before and leave another one running at the proper time, you can throw things in out of sequence, especially like bus transactions and stuff.
What about countermeasures?
Well, basically, using like some type of PLL and some type of feedback loop to make sure that the thing isn't being driven out of skew, or if you have a temperature sensor, if they're trying to cool down the crystal so it operates at a slower rate. You
could also use, I think Maxim makes some kind of watchdog things that need to be either set or reset at a certain time, and that time, well, you could probably use one of those to thwart that. But if your whole system is running off one clock and they're changing that one clock, it makes it difficult to do.
Earlier in your presentation, you were talking about some hardware innovation you were particularly enamored of. What aspects of it caused you to step back and say, yeah, these guys knew what the heck they were doing? But what about that design did you really appreciate?
It was specifically the I hate IBM part number schemes. It's the
3470.
No, the 40. Hold on. I want to get it right because
4758.
Yeah, and it's their PCI secure coprocessor that they had developed. It came out of Watson Labs in upstate New York. What's his name? Steve Weingart. He's been in the building secure coprocessors for a long time. He worked on the Citadel project, and that was the one that they actually used the nichrome wire to protect the actual mechanism, and then they dipped that in epoxy. And he's been around for a long time, and he really looked at it. But he approached the problem of protecting the secure coprocessor by layering the tamper methods. They used epoxy, they used this nichrome weave. They actually had one weave around it, and then they wove it a different way. And they actually I think they had 3 different layers of weave. So if you tried to go in at it at any different angle, you would probably sever something and get busted. They also it was a it would zeroize certain things out. What else did they do right? Just the whole way they set up their manufacturing processes, and they initialized the card at the factory, so if it went in transit, they would be able to detect tamper at the other end by doing a secret check inside the box. So if it had been zeroized, you wouldn't have been able to perform that check. What else? They also had the radiation detectors, which I thought was pretty phenomenal. One thing that was pretty interesting was they had I'm still kind of torn on it, but the way they had the battery, because any type of high current sensor is going to require a battery replacement quite often. A lot of people embed the batteries inside the box, so in order to replace the battery, you have to open the box, tamper it, replace the battery, then reinitialize it and send it back to the customer. With IBM, you had a window where you could pop the battery out, stick it back in, close it, and continue operation. What else? The one downside to the IBM processor was the fact that it was a PCI card, and the PCI card had to go inside of a larger system enclosure, unless you had not a rugged, but an ongoing inspection policy where you have to go and look at the thing to see if it's been physically tampered with. Somebody could tamper with this thing, stick it back in the system, and you wouldn't know if somebody had messed with it because you couldn't see the evidence of it because it was enclosed in this larger enclosure. I think they were the first company to achieve FIPS 140-1 level 4 because they had the temperature stuff in it, but it lost its 4 when you stuck it into the system, and it only became a 3. Any other questions? We could just talk to policies or.
What are your thoughts on Dell's semiconductor iButton?
I like the iButton actually, but he's done a lot more research on it.
Yeah, I actually designed the iButton into a medical product that I worked on a few years ago. To do medical or to keep tracks of the medicines and things like that. There are a lot of different types of iButtons. For those who are wondering, go to www.ibutton.com. There's a lot of different types. We do have the Java Ring cryptographic button. We have some of those. We haven't looked at them too much yet. We are building up our lab, so we'll be able to, and we'll have some space to work on them. But from what we can tell, they look pretty good. They do have some at least their literature says they have some tamper response systems. So if you try to open up the button in some way, it will zeroize the critical memory, and I guess kill any kind of crypto keys that are in there.
The thing I like about it is keys are generated on it, and the secret components never leak out. And I just think that's the proper design for any token-based authentication mechanism.
Actually, here's shameless plug for those who want more information on the iButton. If you go to we don't get paid for this. Go to where is it? I think it's there's the white paper that I wrote that kind of describes some of the attacks that could be launched against it, and also kind of goes into a little higher level review. Just go to loft.com, l0pht.com /kingpin, and then go to the analytical section. There's some white papers there, so that has some other information on it. But yeah, we're definitely going to be looking at them more, and they've caught on a lot in European countries. The U.S. Postal Service uses them here to keep track of their postal people as they go from box to box, but it hasn't really caught on too much yet, and I think it will. Any more?
I think that's great in a military application. I don't know how much, if you're in a multi-level office building and you knock off the thermite charge on the second floor. I'm sure the fire marshal in town wouldn't think too. But you could use tactical amounts of setting off certain things. But I honestly don't know if there's some statute in commercial law governing products. After having that done to it, no, it's physical destruction of the medium, and unless you're an alchemist or something, and you can transmute the melted platter back into a non-melted platter, I don't think you're really going to pull anything off of it. Right. Well, I mean, if you did it right and you did it in like a ring pattern or something, so it just drops right down on top of it. With the Unix box, there's more of a chance of recovering a super block of some sort, but if you blow away the inner track on a standard IBM IDE or something, you're going to take out block 0, hose your fat table. Has anybody ever seen thermite used in a commercial device?
No.
I know the Navy used them on some sub file cabinets at some point, but that's about it that I know of. In commercial environments or military? Oh, really? Cool. Banking, financial, or maybe even in the city somewhere?
No comment. Cool.
Is that under the table, or is that like just a legitimate product, or is this someone's like homebrew idea of tamper response? Oh, interesting. Are you at liberty to discuss that product? I'm just interested. I'd be fascinated to read up on that. Oh, okay. In the works, I take it. Oh, cool.
Cool.
So that's funny.
I don't think that's
Any other questions?
You would touch briefly on Blackhat.
I'm sorry.
If you guys bring the attendance attack,
Yeah.
a particular method of shielding that you prefer overall?
Not really any particular method. There's a funny picture that for the medical device that I designed, we used an EMI spray, which is just a metallic type of spray that was on the inside of the device, which worked pretty well to keep the noise down. It actually worked extremely well, and it helped us pass the FDA requirements. I forget what the dB drop was. If you were really interested in the details of the spray, I could probably dig out some of the test results. But it was really useful, and I think it was pretty cheap as far as compared to actual metal housings and things like that. But there's a funny picture in here. Yeah. Can you see that picture? Or is it pretty dark? That's a completely Tempest-proof PC that actually Dark Tangent took this picture a few years ago. I think he was trying to sell these. But this type of thing obviously isn't going to work for a portable product unless you're Grid or something. But yeah, I do prefer sprays, and it's also because they can put them on at the manufacturing house of whoever's making the housing, so it's really easy. You don't really need to solder on any kind of RF shielding and stuff. So that's what I'd at least try at first. Anything else?
You have a question there?
So any part of the talk that we either went over too fast or you wanted to know more about? Now that there's a huge screen and we can point to stuff.
Yeah. What about?
Do you know key generation programming devices like
I don't know. I want to say the Rainbow iKey 2000, the USB hardware token. Just from glancing at some of their material, I think they generate it on their key. I can't say if they do it right, but I think they do.
I know the BBN Safekeeper does a pretty good job at key generation. They use a hardware, I think it's the Tundra random bit generator on there. And then they also perform a bunch of tests. I mean, anybody who conforms to the FIPS guidelines for, I know 3, I'm not sure if 2 conforms to it, but they have a series of tests that have to be run before the random bit stream can be used as a key. Any other questions on? Are there anybody here from hardware vendors? No. It's interesting. Except you.
Different contractor, maybe.
All right. Well, thanks for stopping in then.
Yeah, thanks.